So as usual, I will answer the questions I got from some students, and then I will highlight Module 5. My lab Module 5 is due this coming Friday, okay? So before we start, are there any general questions? Okay, one question I got is from Module 4, question 12. So Module 4, question 12, okay. You are the manager of a restaurant for a fast food franchise. Last month, the mean waiting time at the drive-through window for branches in your geographical region, as measured from the time a customer places an order until the time the customer receives the order. So the mean waiting time was 3.8 minutes. You selected a random sample of 81 orders. The sample mean waiting time is 3.91 minutes. The sample standard deviation, 0.9 minutes. And then complete part A and B. So part A, at 0.01 level of significance, is there evidence that the mean waiting time is different from 3.8 minutes? Okay, so let's answer this question. Remember, before you answer this question, let's review the basic concept of null hypothesis H0, alternative hypothesis H1. Okay. H0 always connect with equal sign, okay, or greater equal, smaller equal. H0 could be one of these three, and H1 could be not equal, could be smaller, could be greater. H1 will be one of these three, and you have to make sure they are paired together. When H0 is equal, H1 must be not equal. When H0 is greater equal, H1 is smaller. When H0 smaller equal, H1 is greater. So they are paired together. And now look at here, is different. All of these symbols, where do you see the keyword different? Different. Where did you see different? See, this means different. This is different. So you select H1 has not equal. So which one has not equal? Answer A has not equal, H1 not equal. Answer D, not equal. Okay, but hypothesis test always targeting population. When you test population mean, you use mu. Okay, you use mu. You do not use X. Okay, that's why this is wrong, this is correct. And double check H0, you have equal sign here. Okay, sorry, my little doggy. Okay, so the correct answer is A. Okay, any questions? Next one, determine the test statistic. Okay, and so far you have Z test statistic, you have T test statistic. How do you know which one to use? If sample standard deviation is given, you use T. Okay, so the test statistic is you use T. Okay. So the formula is sample mean x bar minus population mu divided by sample standard deviation over square root of n. So this is test statistic. Sample mean x bar, see, sample mean is 3.91. So x bar equal to 3.91 minus population mean. Population mean, say, mu equal to 3.8. Okay. See, this is population mean 3.8. Divided by sample standard deviation, here, 0.9. Over square root of sample size, 81 orders. So sample size is 81, okay? And now you can use Excel to do it. I will just maybe use this space, okay? Maybe here. So equal, on the top you have 3.91 minus 3.8 divided by, on the bottom, denominator 0.9 over square root of 81. Okay, you can use calculator. So if you want to increase decimal places, right click your mouse, format cells, number, depending on the requirement, test statistic 2 decimal places. The requirement says 2 decimal places. So it is 1.10. Okay. So this is a test statistic. Okay. Any questions? So next one, find the p-value. Okay. Remember what is the p-value? In the graph, in bell-shaped graph, p-value is the area corresponding to test statistic. So you get test statistic 1.1, 1.1. Because this is a two-tailed test, how do you know it is two-tailed? You see this one here. H1 said mu not equal to 38. That means this is a two-tailed test. Okay. This is a two-tailed test. When you have two-tailed test, you have another tail. So p-value is this area plus this area. Because of the symmetry, you just need to figure out this area and then multiply by 2, you get p-value. Okay, so let's find this yellow background, this area here. Okay, use a calculator to find the p-value. So to find the p-value, you press F5 and then F2. Okay, so to find the p-value, you press F5, distribution, F5, and then F2, T distribution, and then F2 again, accumulative. Okay, data variable, log, see this area here, this 1.1 is log. Okay, so log, you type in 1.1, upper you type in 10,000. There is a very big number here, 10,000. Okay, because this bell-shaped curve extend forever. but we'll never touch this x-axis. Okay. So upper 10,000, and then degree of freedom. Sample size -1 is degree of freedom. Sample size is 81, -1 is 80. So, and then press EXE, okay? And you get p-value 0.1373. Remember, this value is just one tail. You have to multiply by 2, okay? So I'm going to use Excel to do it. So 2 multiply 0.1373. So this is p-value, okay? It is, looks like my OneNote has some problem. So anyway, you know this value has to multiply by 2. What happened? Okay, any questions? So this is question 12. Remember you multiply by 2, okay? So I can't move my mouse. So I have to quit this OneNote and start all over again. So I'm going to force quit. And then I will, there was a problem, okay. And then I will open it again. All right, so module 4, okay, we are here, okay. Module 5, module 4. Try looking for module 4. Looks like my notes disappeared because I forced quit. Question 12. Oh yeah, we are here. Okay, so maybe I will just increase the font size. Just try to increase the size. Okay, it's better. Okay. So where is my question? Question 12. Looks like it's frozen again. Okay, here. Okay. This is typical hypothesis test for one population mean, okay? And we used test statistic to draw conclusion. And also you can use p-value. Okay. Once you get the p-value, the universal rule is when p-value smaller than, okay, once you get p-value, when p-value smaller than alpha, you reject H0. Remember, you reject H0, not H1, okay? You reject H0. And when p-value greater than alpha, you do not reject H0, okay? So that is the p-value method. Do not reject. Do not reject H0. Okay. So what is the p-value here? See, p-value is 0.01, or not, just alpha 0.01. So my p-value is, where's my p-value? It is on Excel. No, it's on my calculator. P-value equal to 0. From my calculator, F5, F2, F2, my p-value 0.13, 0.1373. Okay, this value multiplied by 2, you get final p-value 0.2746. This is the p-value. And this p-value obviously greater than alpha. Alpha is 0.01. When p-value greater than alpha, you do not reject H0, means H0 is correct. Mu equal to 3.8. This is the p-value method. Okay. Another method to use test statistics. See here, we get our test statistic T is test statistic 1.1 is my test statistic. You compare your test statistic with the critical value. And how do you find the critical value? You use a calculator. Okay, critical value. So if you have calculator with you, critical value, you press F5. Distribution, and then F2, T distribution. After that, F3, inverse T. And then on your calculator, you have inverse student T, data variable. Area, okay. Half alpha is the area. Half alpha is the area. Because you have two-tailed test. If you have one-tailed test, alpha is area. Okay, so area you type in 0.01 divided by 2. That is your area. Okay, 0.01 divided by 2. That is your area. And then degree of freedom. Sample size -1. So 81 minus 180 is degree of freedom. And you press Enter key. Okay, EXE key. And you get from here, what is the critical value? 2.6387. 2.6387. That is your critical value. Okay, so in this diagram, Y is 2.6387. Okay, it is here. Critical value decide rejection region. So from here, this is rejection region. Okay, if test statistic is in the rejection region, you reject. But our test statistic is here, 1.1, is not in the rejection region. So you do not reject H0. And you get the same conclusion as from p-value method. And this one we use test statistic. Same conclusion, do not reject H0. Okay, and this is very fundamental for hypothesis test. Make sure you are 100% comfortable with p-value method, test statistic, critical value method to do what? To do hypothesis test. Okay, so this is the calculations for test statistic and p-value. Any questions? I also get questions from one student. The student asked, can I get test statistic and p-value from calculator? The answer is yes. So this is the one we are going to turn to. How do I use calculator to get test statistic and to get p-value. Okay, so if you have, by the way, when you attend this lecture, I strongly suggest you have your calculator ready. Okay, have your calculator ready, and then you can follow my steps and you can stop me for any questions. Okay. All right, you ready? Calculator to get test statistic and p-value based on just original data here, no formula, just punch in the calculator. Okay, so you do F3 test, starting from F3 test, and then F2 T test. After that, F1 one sample. Okay, now on your calculator, you have one sample T test, data variable, and then you have mu 0. Okay, you have 3 choices. Remember, calculator is based on H1 perspective. Calculator is based on H1 perspective. When you look at your calculator, when you have one sample t-test window, on the bottom, you see not equal, you see smaller, you see greater. Those are H1. Okay, so calculator is based on H1 perspective. And once you are here, and there are 3 symbols on the bottom, how do you know when do you select which one? There are 3. Okay, you select the first one not equal when you have 2-tailed test. You select smaller when you have left-tailed test. You select greater when you have right-tailed test. Okay, so for now, see our question we have, oops, so I messed up. I just click undo button here. All right, so things, okay, great. So our hypothesis is 2-tailed test. It is here, okay? So that's why on your calculator, mu, you select not equal. Use F1 to choose not equal. Mu not equal to mu 0. And mu 0 is the hypothesized number. That is 3.8 is mu 0 on your calculator. And then your calculator asks you X bar, means sample mean. You type in 3.91, that is your X bar. And your calculator asks you SX, means sample standard deviation, that is 0.9. Okay, and lastly, the calculator asks you sample size N. Type in 81. Do not type in 80 because you are asked for sample size, not degree of freedom. Okay, so I repeat because this procedure is important. How do you get test statistic and p-value from calculator? You start from F3, F2, F1, and then you select mu not equal to mu 0. Mu 0 type in 3.8, X bar type in 3.81, SX type in 0.9, sample size N 81, and then you're ready to go. Just press EXE button. Okay, sometimes you need to press 2 times. Okay. Okay. Hold on. One sample t-test. See result. Okay. EXE. Okay. So after EXE button, you have T 1.1 from your calculator. You have T 1.1. And you also have p-value 0.2746. See, exactly the same as we get from previously. Okay. All right, any questions? Any questions? All right, so this is this question. And then I have somebody ask question 18. Yeah, question 18, oops. This is researchers determined that 60 tissues is the mean number of tissues used during a cold. Suppose a random sample of 100 tissues yield the following data on the number of tissue used during a cold. X bar equal to 52, S equal to 22. Suppose the test statistic does fall in the rejection region at 0.05, which of the following decisions is correct? This is the question. It is said test statistic in the rejection region. When test statistic in the rejection region, you reject H0. Okay, but why answer B is not correct? Because answer B said at alpha 0.1. The question asks you at 0.05. So the correct answer is A, reject. Okay. And if I further ask you a question, I will type in the question, okay? The same question I will type in. Not sure if I can type. What is test statistic? What is p-value? The same question. Okay, and any idea how do I approach those? How do I figure out test statistic?
You can find the test statistic by entering F3, F2, F1 on your calculator.
Perfect. Okay, you can do it by enter F3, F2, and then F1. Let's do it together, okay? So F3, F2, F1, and then mu not equal to mu 0. Mu 0, okay? Mu 0 is 60. 60 is mu 0, so you type in 60. X bar is 52. You type in 52. SX, you type in 22. Sample size, how many samples? Sample size is 100. Okay, you type in 100. Okay, I repeat, you type in F3, F2, F1, and then select mu not equal to mu 0. Mu 0 is 60, X bar 52, S, so I have to go back because SX is 22, mu is, N is 100, sample size 100. And then you press EX, EK. And can anyone share your answer?
Negative 3.64.
Thank you so much. So that is the t-value, okay? If you want 4 decimal places. And what is p-value? What is p-value? the p-value you get is scientific notation. You get 4.4 times 10 raised to power negative 4. You need to know how to read that number. It is the same as this number here. Okay, on your calculator, you get this. You get 4.4, 106, and then E, negative 0.4. This is scientific notation. E, negative 0.4 means move decimal places, these decimal places to the left 4 times, and you get this number. Okay, so by using F3, F2, F1, you get both test statistic and p-value. Okay, so that is the question I get from, I collected from module 4. And then I also have, now let's go over, maybe I will open it up to see if you have any questions before we go module 4. Module 4 due date this coming Friday, okay? So I will open module 4 first. Where is my module 4? Here we go. This is module 4. I need module 5. I need module 5. Where is my module 5? All right, looks like I lost my module 5. Give me 1 second. I'm going to get my module 5. How come? Very strange. I will open module 5, okay? It is here. I'm just going to grab a bottle of water, okay? So where is my module 5? Did I have module 5? Great, this is module 5. Excellent. Let's see, module 5. I have to see my module 5 is the test for 2 samples, 2 sample independent test. Last class, last lecture, last Saturday, I did 1 example, okay, for independent sample Z test I did. So there are, so this is a module 5. Yes, I got actually 1 question. Maybe let's start off. No, this. Yeah, starting from here. So let's start with the basic. Okay, go over a couple of questions. But before we start, do you have any other questions? Okay. So this one, in testing for differences between means of 2 independent populations, what is the null hypothesis? See the keyword difference. Difference means not equal. Okay, not equal. And where can you see not equal? Only H1 can have, so this one is very important. Only H1 can have not equal or smaller or greater. H0 always have equal or greater equal, smaller equal. Okay, but the question asks you, null means what is H0? The question not ask you H1. Okay, so when you have not equal as H0, you must select this pair. So H0 said equal. That's why Y is equal. A is equal, C is also equal. But equal to 0, C said equal to 2. So only A is correct. All the rest are wrong. Okay. So question 2.
Is it okay if you can repeat that?
Yes, questions?
Is it okay if you can repeat that answer?
Oh,
Like,
sure. Yeah, this is important. Thank you for asking.
Thank you.
The original question said, testing the differences. You see the keyword differences means H1 not equal. That means difference. Okay. When you have H1 not equal, H0 must be equal because they are paired together. Okay. So in A, B, C, D, you only select which one, and the question asks you, what is the null hypothesis? Null hypothesis means H0. So H0, H0, they're all correct. A, B, C, D. See, H0, 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 H0. Okay. And A, B, C, D, you only select equal. This is equal, this is equal. Okay. Why B is wrong? B said smaller. H0 will never ever have a smaller sign. H0 only have equal, greater, equal, smaller, equal. H0 never have this smaller sign, so this is wrong. Okay, and C is wrong because it said 2. Okay, usually it is 0. D is wrong because it said greater. H0 never have greater, so it is wrong. The only correct is A.
Perfect. Thank you so much.
Thank you for asking. Please, other students, feel free to jump in, okay? So question 2. In testing the differences between means of 2 independent samples where variances are unknown but assumed equal, how many degrees of freedom are there? When you have variance unknown but assume equal, the calculation for degree of freedom, sample 1 size plus sample 2 size minus 2. This is formula. Under what condition? Under you do not know variances in each population, but you assume those 2 variants are equal. So the degree of freedom is this one. N1 sample 1 size, N2 sample 2 size. Okay. Next question. If you have 2 samples, sample 1, 14, sample 2, 22, in performing the pooled variance, how many degrees of freedom? Pooled variance. For pooled variance, it is also have degree of freedom N1 plus N2 minus 2. So you use 14 plus 22 minus 2, you get the answer. Okay. Any questions? By the way, pooled variance is the same concept as variance in population are unknown but assume equal. Those the highlighted part are equivalent. If I say pooled variance, in another word, I say variances in each population are unknown but assumed equal. So question 4. I let you read the question. This is a very good question. So the question asks you to compare two population mean. The question said if population 1 mean mu1 greater than population 2 mean mu2. That is the question mark. That is the question mark. And alpha equal to 0.01. Okay. So did you see this greater sign? When you have this greater sign, we have seen this sign, means H1 is greater. If you see this, only H1 has this greater sign. Okay, so you go back here. You choose H1 have greater sign. This looks good. H1 smaller equal. If you see H1 smaller equal, this must be wrong. H1 not equal, this must be wrong because you need H1 small greater. And this one, H1 equal, this is wrong. And then double check H0, mu1 smaller equal to mu2. Bingo. See, when you have H1 greater, H0 must use smaller equal. They are pair. Okay, so it's like you have to pair. Okay, how do I get greater H1? It is given. See here. See, mu1 greater mu2. It is given. I am asked to test if mu1 greater u2. Oh, I remembered. The one question said, isn't the question ask you mu1 greater mu2? Yes. The question asked mu1 greater mu2. And then the student asked, why don't select this one? See, mu1 greater than mu2. That is the question from one student. See, the question asked me mu1 greater mu2. Why I don't select mu1 greater than mu2 D? Why I don't select D? Can anyone comment? Why?
Because it's not paired. As you mentioned, H1 and H0 have to be paired together.
Thank you so much. This D said H0 greater. H0 will never have a greater sign. This is wrong. Go back to H0. H0 only allow 3 signs. H0 either equal, greater, equal, or smaller equal. Do you see H0 have a, what is this one, D? H0 have a greater sign? No. See, H0 do not have a greater sign. Which one have greater? See, H1 has greater than. H0 will never have a greater. So this D is wrong. Is that clear? So you have to remember this. This is very important here. Okay. Which sign can use as H0? Which sign can be used in H1? Okay, let's go back here. So the only correct answer is here. Any other wrong answer are wrong. You need to know why they are wrong. Why they are wrong. Okay. So this is A. Then found the test statistic. Okay, found the test statistic. Test statistic, you use formula. Pooled variance. Okay, pooled variance. So the test statistic is a formula. The formula I will write down here. The formula said T equal to, it's way too big. Sample 1 average minus sample 2 average. So where is X1 bar? See here, 49 is x1 bar. Where is x2 bar? 34 is x2 bar. Okay, then minus bracket hold on. Yes, bracket population 1 mean mu1 minus population 2 mean mu2. And then divided by square root of pooled variance SP square. I will talk about SP square, give you formula in 1 second, times 1 over N1 plus 1 over N2. Okay, so we know x1 bar, x2 bar. So what is mu1 minus mu2? Okay, what is mu1 minus mu2? Mu1 minus mu2 is 0, because when you have, say, mu1 smaller equal to mu2, some textbook use smaller equal, they just say equal. Okay, so mu1 minus mu2 equal to 0. And then what is this SP, pooled variance? Pooled variance equal to sample 1 size N1 minus 1. N1 is given, say 5, okay? And times sample 1 standard deviation square. So S1 square, see, S1 is given. So 6 square, you have to square it. And plus N2, sample 2 size minus 1. N2 is 7 times sample 2 standard deviation square it. 7, you have to square it. And then divided by sample 1 size N1 minus 1 plus sample 2 size minus 1. So N1, N2, you know, so you can calculate SP square. Any number on the right-hand side, you know, it is given here. Okay. And then you plug in this formula, you can get T. Okay. So that is the formula method. Now, you may wonder, is there a calculator method just punching the numbers from the given? Yes. Okay, so let's do the calculator, okay? How do we get test statistics from calculator? Okay. So calculator. Make sure you are at home page. You start with F3, sorry, my dog. F3 test, and then F2 T test. And then this is 2 sample, F2 again. I repeat, F3 test, F2 T test, F2 2 sample. Okay. And then you have a data variable. Mu1, mu2. There are 3 possibilities. On the bottom of your window, it is H1 perspective, okay? Calculator take H1 perspective. You should look at mu1 greater mu2 on your calculator. Type in mu1 greater mu2, okay? Press F3, you select mu1 greater mu2. And then move down x1 bar, 49, type in 49, sx1, 6, n1, 5, x2 bar, 34, And then down arrow key, okay? You have SX2 means sample to standard deviation enter 7, SS2. And N2, what is N2? N2 is 7, okay? And then poured on, make sure you have poured on, and then you press EXE. Anyone want to share your result? What test statistic do you get? You have T equal to 3.8708. Okay, 2 decimal places. There are, sorry for the noise. Okay, and you also get a p-value. This is the T test statistic. You also get a p-value. P-value is 1.55, 1.526. It is scientific notation. E -0.3. And this is the same as move this decimal place to the left 3 times. So you get 0.00155. Okay. So any questions? You get test statistic and p-value. Let's double check. All right, in summary, what we did in this lecture, we did some problems from module 4. And then we go over some questions from module 5. Okay. Module 5 are about 2 sample t-test. Module 4 is about 1 sample. Okay. Any questions?
No, thank you so much, Professor.
Okay, thank you for your participation. All right, that's all for tonight. Thank you so much. Good night, and I'll look forward to see you next Saturday. Okay.